Mapping. As promised, nothing too crazy here, just a new way to write things. In fact, most people think this is the easiest way to write what's going on in these crazy functions. So, functions as mappings. Mappings and mapping diagrams. A graph that relates numbers in one set of numbers to another set by means of arrows is called a mapping diagram. In fact, I'm convinced if I took mapping diagrams to you and showed them to you in any grade, you'd go, oh, I understand what's happening here. It's a little easier than graphs, it's a little easier than equations, but it's pretty close to what a table of values is. So for instance, if I have a list of numbers over here and just arrows to show where they're going. In fact, I think in lower grades they use mapping diagrams to teach stuff, to go, here's what's going on with the numbers. And you can copy down all the individual numbers that I put here, but I'm not actually going to use those numbers. I'm just showing this is what mapping diagrams look like. Usually an oval, but there's no reason it has to be an oval, but a nice oval on one side and a nice oval on the other side, and you just show where the x's go and where they end up as the y's. This relation is referred to as a mapping. And on the upcoming quiz, there's one easy question about mappings where you just go, okay, what's this mapping here? You know, like so. Slide 1 of 6. I only have 6 slides to go through for you. I know you got a lot of copying to do. Except you iPad people. Where's the iPad people? Do you already have this note? No, you like copying it out anyways, don't you? Yeah, that's smart. But if copying drives you nuts, I put the notes up in advance. You could print them out and just copy off of there. Okay, so far, Mr. Todd, if I put all the numbers, the x's in an oval, and draw arrows to where they go as y's, you're going to call that a mapping. That's all you've taught so far? Yep, pretty much. Do you have any questions about mappings, though? I was going to ask, do you need more time, but I can look right over some people's shoulders and see you do need more time. Question? I think the words that have gone off the screen are called mapping diagram. On the next page, I'll use this zoom, but I'll play around with the picture itself. Hi. Do you need more time? Who needs more time? Yes? Okay. Well, that's why I brought my cube today. Wrong way. Double wrong way. More time? All right. Needs fixing. Okay, here we go. This says graph each of the following functions on a mapping diagram. So what I mean by that is, and let me just do a little playing around with the zoom here to try to make it as good as possible for everyone. I just do that and then switch to, what was I, 200% zoom, and then do that, I think I've now made it as big as I possibly can there. Okay. Now it says graph, and that's going to mess you up. That's the only one thing that could mess you up here. It says graph, and you're immediately thinking graph, x, y, coordinates, all that kind of stuff. But when it says graph, it doesn't mean do that. It means do a mapping diagram. Graph a map. So I'm going to get two ovals here. Now it says do the values between -3 and 3. And if you have trouble with these, just go over and first build your table of values. So x, y equals 3x minus 1. And I'll show some of the subbing here, but maybe not all the subbing. They want -3 to 3 inclusive. So if I put -3 in there, I go 3 times -3 minus 1. And that's -9 minus 1 is -10. Good. Now if I sub in, oops. If I sub in -2, I get 3 times -2 minus 1, which is -7. If I sub in -1, I get 3 times -1 minus 1 is -4. Does this remind you of yesterday's homework, the weekend homework? Subbing, 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 subbing. Are they just torturing us and making sure we can sub in here? Is that all this homework is? And the answer is, yeah. If we're going to move forward, we got to be good at subbing things in. So there's lots of subbing in. But maybe you can keep subbing if you want. Maybe you see the pattern here. This is just a line. It starts at -1 and goes up by 3s. So I'm just going up by 3s. So -1 and then 2 and then 5 and then 8. I'm not saying don't sub in. That's not what I'm saying at all. But if you remember the stuff from grade 9 said, okay, this is a line with y-intercept -1 and it's going up by 3s. That kind of patterning has been going on for a while. So yes, sub in, but maybe after a few subs you're like, oh, I see what's happening here. I don't need to do all the individual subs anymore. I get what's going on here. That's not exciting. That we should have down pat. Drawing the mapping diagram, that's new and exciting. So the mapping diagram says, draw an oval, put your x values in there, -3, -2, -1, 0, 1, 2, 3. Draw another oval and put the y values you found in there, -10, -7, -4, -1, 2, 5, and 8. And then just draw arrows. They don't need to be a separate color, but I'll do it so you can see. And just draw arrows that match up the x values with their matching y values. Why do I care, Mr. Todd, about this? Well, mapping diagrams are very visual. It's very easy to see what's happening. Second, it's easy to see the domain and range. In the first oval's the domain, in the second oval's the range. So there's some advantages of mapping diagrams right there. There's more advantages to come, but there's a couple of advantages right now. G at x equals x squared. Are we good enough at x squared to not have to build the separate table of values? I hope so. I hope you can go, okay, here comes the x values they wanted for this question, -3, -2, -1, 0, 1, 2, 3. Now the y values. Can I just square them in my head without going through all this to build the table of values? I hope so. -3 squared, that's 9. -2 squared, that's 4. -1 squared, that's +1. 0 squared, that's 0. 1 squared, that's 1. 2 squared, that's 4. And 3 squared, that's 9. Do you have to do it one step like that? Absolutely not. You can get your calculator out, build the table of values. If the function's too hard for you to do in your head, absolutely. But mapping diagrams don't have to take that long. They can be very fast if the numbers that you're subbing in and the function you're using are reasonable enough. Do you have any questions about those two examples?
What's your first number in the second example?
-3, 9.
That's a 9?
Yes, it's a 9. Let's see if this final sentence is interesting, though. When using a mapping diagram, the first set of numbers at the tail of the arrows is the, what are these called? I know they're called x values. What's the other word we've been using for all the x values? He's pausing. This must be important. All the x values are called the domain. And the second set of numbers, the ones at the head of the arrows, is called the range. Maybe you knew that, but you weren't sure what I was looking for there as I said that, but now you see it. Okay, easy to see, domain, range. So a little easier to see here in mapping diagrams. I'll give you time for that final sentence. Maybe you need a little time to copy that down. Ooh, 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 ooh. That was slide 2. Why does it say 6 now? Was it always 6? That was 5. Stressed. Do you have any questions? If you don't have questions and that bothers you, you're like, I've been having trouble in this course. Why is this so easy? Yeah, easier chapter here in a lot of ways. Just some words. Lots of subbing is in this chapter for sure. Do you need more time? More time? Yes, I'll give more time. More time? We good? All right. I put the completed notes up at the end of the day, too. So if you ever want to look them back over, you're away from them. The completed notes are up there and the videos normally, but I forgot 2 days in a row to make a video, so those 2 lessons don't have videos. Question, how can I tell if a mapping diagram represents a function? It's much easier than the previous situations. Were these both functions? These were, because every x value went to every y value. So there's a nice easy way to see if something's a function. If any x value has 2 arrows, then it's not a function. How can you tell if a mapping diagram represents a function? Every x value has 1 arrow. Not that deciding if something's a function is extremely difficult. It's probably not extremely difficult, but it's really easy here. You just look at it and go, does each x value have 1 arrow? So take a second and try those 2 examples. Copy them down. Maybe I'll zoom in on those a little bit. After you got the question part done, I'll zoom in on them a little bit. Can I zoom in anymore? They're far apart. I don't know if I can. How can we tell if a mapping diagram represents a function? Every x value has 1 arrow. Do you got that first part? So I can zoom in on the second part? Yes? No? 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 No, they say. Each page have less on it. Sorry, I just wanted to see if there's anything else on that page, but there's not, so that's good. First question's okay now? I can zoom in on the next part? Okay, I'll go down here. I'll do a little extra zooming here. I did there. I think I've zoomed as best I can on that second part. So is the first one a function? No. Easy to see. Which x values fail? 1, 4, 9. See right there, 1 fails. It's heading to 2 different y values. Perfectly allowed in math, just not called a function. 4 fails and 9 fails. They both are heading off to 2 different numbers there. What about the second function? Is that one a function? Yes, because every single x value heads to 1 y value. Any questions on that? That should tie together well with what you know about functions so far, and maybe the easiest version of that so far. Even off a table of values, sometimes you got to really look closely. And certainly on a graph, you got to look closely. But on a mapping diagram, it should be very clear whether something's a function or not. As long as you know what a function is, certainly better write that down and go, I've got this down pat for, what did I say? Thursday's quiz. I just wrote it on the board there, Thursday's quiz. Do you need more time there? Yes? I'll mess up another cube while I'm waiting. And we're for sure at least halfway done. Not a long one today. There's nothing on the quiz from Wednesday's work. Yes? Tonight is the last. Was it the third one? 3 sets of homework. Yeah, and I'm stealing questions essentially right from the homework. If you know the homework, you'll kick the crap out of the quiz, and I'll even give an updated mark. And then the assignment is not difficult. It's just a step-by-step investigation. You'll see tomorrow. You have all tomorrow's period to work on the assignment. I'll have copies for you, ready to rock and roll. But you can peek. I think it's already up online. You can already see it. You can peek and see what it looks like. iPad people, you can do it on paper, or sorry, you can do it on your iPads. But I have some rules. I'll mention the rules by the end. And there'll be drop boxes. More time? More time? Yes, more time. Yeah. So, I'm going to hand back your test in just a few minutes. Silly, why did you do that? Oh, aren't you clever? You're now using the phone to see the note at the same time, aren't you? That's good. That's good. We'll get there. Advanced functions is all notes, so I'll slowly transition you guys over. More time there? If you're trying to manage your energy, 4, 5, and 6. There is 3 more slides. Consider the following mapping diagram. Write the function represented by the mapping diagram as a set of ordered pairs. What? Actually make the pair, the xy pairs. For instance, the first pair is -2, 2. So it's just taking the information that's on the mapping diagram and putting it back into pairs. What was the next one? -1, 0. Oh, I don't like that. What a mess I'm making. Next one, 0, 0. 1 maps to 2. Look, I'm even starting to talk as a mapping person. 1 maps to 2, 2 maps to 6, and 3 maps to 12. I've got 6 points. Was there 6 arrows? Yes, that makes me feel pretty good. Now, technically speaking, when we make a list of things in math, we should put the fancy set notation brackets, they're called, these little curly brackets. Am I about to bust you for a half mark on the next test if you don't do the set notation? No. I'll be sad if you don't use them. But I'll be so happy to see the list of ordered pairs that I'll take it, and you'll see me in red write the set notation on there, and you're like, oh, he doesn't like that. Yeah? So think about using the set brackets. They're important moving forward. Every time you make a list in math, you put set brackets around it. You may have found domain and range hard in certain homework questions. It is very hard. But it wasn't these situations. The domain here is easy because I just have to list the x values. What x values were the domain? -2, -1, 0, 1, 2, 3. The idea of domain is pretty easy. Just list the x values. But on continuous graphs, on functions that are connected up, it gets hard to list, and that's where those interval notations come in, and they get very difficult to write. So the range here, just the y values, 0, 2, 6, and 12. It didn't ask. Does it ask? It didn't ask, but is this a function? Yes. Every x value has one arrow on it. For those of you heading off to advanced functions in calculus, this function isn't one-to-one, though. The y values don't have only one arrow coming to them. That might matter later. It doesn't matter to us now. We don't care about that. But it will matter later in some of the stuff we're doing later. Do you have any questions about that example? Slide 4 of 6. What's the question? I'd love to answer a question while I'm waiting here.
What room number is math help room?
2076. Senior math help. It's very, very near the office, very near student services. Yes? And I go there every day at lunch. Not because I don't have any friends, because I'm waiting for senior students to come and ask for help. So I sit there with Mr. Jaszczorski. I don't know if you met him yet. Also a wonderful help. So if I'm happen not to be there for a second, he can answer all the questions too. Usually, it's right after the second test that the math help room fills up with 11 new people. So don't be shy about it. It happens every year, all the time. 11 U's go. In chapter 3, they go, oh, I got to get it together here. And then things, slightly easier chapters, slightly better work ethic, asking for more help, and everything works out. Okay? So we'll get off the panic button a little bit. How did I do? Did I kill enough time? Do you need more time? All right. 2 more slides, and then we're done. We might be done before 11. Mapping notation. Yet another type of notation. But okay, maybe I'm not the best guide, but I hope you're going to like this. It's a smooth way to write things. It really shows what's going on. Let's pretend you got this far and you're like, I really don't get function notation. I really don't get what's going on. I'd probably show you this and go, here's all that's happening here. Here's what we're trying to accomplish. As you can imagine, it would be impractical to draw mapping diagrams for functions containing many ordered pairs. The mapping diagrams are great when there's 5 or 6 numbers and you can see what's going on. But if there's like an infinite number of numbers, or even like 20 or 30, mapping diagrams aren't so good. So we do a mapping equation, basically. You can use, it's called mapping notation. The function f at x equals x squared can be written in mapping notation like this. And if you're madly copying, I'll give you time to copy. Just look what I write so you see, as I explain it, this different way to write functions. It looks like this. You want to know what the function f is? So I put f with a little colon there. I go, here's what the function f does. It takes whatever x value you have, so whatever you get given, 2, 4, -7, any x value you want, and it maps it over and turns it into x squared. That notation explains better what's going on here. X's become x squareds. And if you wanted to say that out loud, you say f is a function that maps x onto x squared. X values become x squared. So 2 becomes 2 squared. 5 becomes 5 squared. 8 becomes 8 squared. And if you're right with me, you're like, isn't this the same thing we've been talking about all the way along? You've just wrote it a different way? The answer is yes to that. But this shows a little bit more of what's happening. F at x equals x squared can be confusing to look at first. But this really shows what's happening. F takes whatever x value you have and it turns it into x squared. But do you have questions about that? You might be like, so instead of writing f at x equals x squared, I write f colon x to x squared. I'm going to write underneath something you don't have to write. But it's more how I think about it. I think of it this way. F colon, like that. And that little space really helps me to understand what this is saying. It's saying, here's f. If you want to talk about f, let's talk about it. It takes x and turns it into x squared. So this might turn into, the red version of it might turn into symbol gibberish in your head. You're like, I don't know what this is saying. But all it's saying is, you want to know what f does? It turns x into x squared. That's all that's going on. Do you have questions? I know there's a lot of writing there, so I'll give you time. That writing's so good for you, though. I know you don't like it. I know. There's something about writing with a pen and your brain. It pushes things into your brain. I don't know. We're programmed like that. Oh, there it is. Get in there. Has anyone played one of my videos on 1.5 or 2 times speed? Do I sound like a chipmunk? Has anyone done it yet? That's good, right?
I tried it at 2 times, it was too fast.
Yeah. Most people like 1.5. Maybe you want 2 because you want to get through it really quick, but 1.5 seems to be a good pace. Especially a lesson like this that has a lot of pauses in it. At least it gets through those pauses a little faster, yeah?
With 2, my injury, I had a teacher who recorded all their stuff.
Yeah.
So if you missed a day, you could just go back and put it on that. And she talked slowly, so I could put it on ×2. But this is way
I'm a little faster, yeah. I do talk fast. I'm bad for trying to get a lot of information out in a hurry, yeah. Do you need more time there? Yes, more time? Yeah. It's okay, we only got 1 slide to go. I'm going to hit my 11 o'clock deadline today. Aren't you excited? That's something else that's easier about Chapter 3. Sometimes the lessons aren't quite so long, which means you can get some time in class to get some work done. red, blue, green, orange. Oh, that worked out. What's going on? Still more time? Are we okay now? All right, last slide. Write each of the following using function notation. Sorry, using mapping notation. That's the new mapping notation. Let me help you out in case you're madly copying and didn't understand what it was. With mapping notation, I'm always going to start the same way. I'm going to go F, and I'm going to write a colon there. Just to go, here comes what F is. Instead of writing F at X, I write F with a colon. Same here. F colon. F colon. That's always how function notation starts. Question? I'll do one at a time and I'll zoom them in, okay? There's 200. Good? Try when I make flip charts now to make them bigger. Okay, the second part says, what does F do? And look at, I'm leaving a little space there. I can't resist leaving a space there. I just over here and go, X. What happens to X? What does this function do to X's? Yeah, it just turns them into that. It just turns them into x squared plus 2x minus 3. You're waiting for something harder, maybe. You're waiting to go, okay, so where's difficulty here? It is, some of you will like this chapter better because it's a lot more words. As long as you know what the words mean, you're okay. It's less algebra most of the time. Yeah? Some won't like that. They're like, I just want to do the algebra, thank you. I don't want to have to memorize all these words and new notations. So the second one, it says, it's actually in a set notation here, but I've got the function right there. Y equals 3 bracket x minus 1 squared plus 1. So what does this function do? It takes x values and it maps them over and they become, oh, I don't want that little mess there, 3 x minus 1 squared plus 1. Maybe you're sitting there going, wait a minute. All I got to do is go x and do an arrow to whatever the y value is or to whatever the function notation is. I'm like, yep, just whatever the y is, or whatever the x is, you're just saying x becomes that. Okay, well, what would you do? If on this quiz I asked you for a mapping diagram and someone just wrote the second part, if they only wrote x arrow 3x minus 1 squared plus 1, would you take a half mark off? Because they didn't write the F colon? Some people nodding and some people shaking their heads. And I don't really have an answer for that today per se, but I do want you to think about that. On a quiz that's coming up like this, that isn't quite so pressure-filled, boy, you don't want to take a chance. You want to know this stuff really well. And studying really does help. Looking it over the night before and going, okay, with function notation, it's like this. And I don't know, is there anyone taking biology right now? Have you made cards yet? The cards, like, no one showed me the cards until second year university. Just getting those recipe cards, write something on the back and something on the front. Because you can study things while you're doing other things. You can have your study cards with you. You can be on the bus looking at your study cards. You can have a TV show in the background looking at your study cards on the commercials or something like that. Especially sports, watching sports. Sports in the thing and you're flipping through your cards. It uses a different kind of brain for somehow. And instead of this crazy, your head's hurting doing your homework, you're just going through your cards and going, oh, this is what this one looks like, this looks like. So you could have a card that said mapping notation. And on the back, it says F colon X to whatever. It just shows an example. And in your brain, you're like, what does mapping notation look like again? And you're just making those associations. So on test time, you're like, boom, 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 done. So some people that do better on tests They might not, they don't have to be smarter than you. They just have come up with a program of going, I'm going to make sure I know the basics when I get there so that I don't get myself into trouble with words and the basics. Do I have enough room to just scroll down there now? Last one, F colon X maps to 1 over X plus 2. But we do need the restrictions there. X can't equal -2. Lots more coming on restrictions. Do you have any questions there? Questions on one on the video, but the copying time, I can leave this on forever, so